Share. All right, guys. So we're going to be proving theorems about triangles. So you guys might have heard the side theorem, the side angle side theorem, and what was the other one? Angle side angle theorem. So we're going to be talking about those today. If you haven't, we'll go into them. In this lesson, we will prove theorems about triangles. That's one of the most broad objectives we've had so far. So triangles have rules. So the thing is, how do we know if triangles are exactly the same? Well, we can say all the angles are the same, all the sides are the same, but that feels like we're just saying way too much at that point, right? So we're going to talk about how we can figure out interior angles of triangles. So I'm not sure if you guys know this or not. I think we've mentioned it a few times, but triangles do have 180 degrees. If you guys ever need to know how much angles a polygon has, all you need to know is the number of sides. It goes by a theorem that's like this. N minus 2 times 180. What the n is the number of sides. So for example, if you have a triangle, 3 take away 2 is 1 times 180. But if you have like a square, well, a square has 4 sides. 4 take away 2 is 2. And then when you multiply it by 180, you find out that you need 360 degrees. Hexagon, same thing. You plug in the 6. Pentagon, you plug in the 5. Over and over again. So you guys don't need to know this, but I always try to point it out just in case you guys forget. Just remember a triangle has 180. So if you add another side, you're adding another 180. If you add another side, you add another 180. So that's the main idea there, is that every time you add another side, you're adding 180. So we're going to probably prove that right now. So interior angles of a triangle. So right here, they want us to measure the interior angles. So we've done this a few times, how to measure angles, but here they're pointing them out to us. Oh, and they gave us a right triangle. So this one's pretty simple. They just want us to put them all in, and then they want us to add them all together. So for this one, alpha. Alpha is 90. I'm not going to put the degree symbol because I don't want to go into the equation editor. We don't really need it. Beta is 53.13. And gamma is 36.87. 36.87. If we add these all up, if we add these all up, 87. I don't know where that 3 came from. We should find that they equal 180. So give us a second. Give me a second while I prove that. Less GeoGebra's off. This should equal 180. Yep, 180. So that's all we do for that one. So now it's like move these vertices around and then record the angles. So that's simple. We're just going to grab one of these angles, move it around, record our new angles. Can I copy this? Is there a way for me to just copy this? No. But can I copy it from here? No, doesn't look like I can. I was hoping I could, but I can't. Okay. Well, I tried. So let's plug them all in. So this is just a bunch of just checking it and verifying it that this theorem works. Beta is 78.66. If you guys don't have this part, the algebra part, I can show you guys how to access it. So give me a second. So what you would do is you would go into this, hit these little three dots and click algebra, and it shows you this. This I like using because it makes it a little easier to read some of the symbols. 78.66, I think I entered that one, and gamma is 59.66. Now here's the thing, 72. And then we're just going to say that equals 180. So you guys can just do this on your own. If you need help, like moving with GeoGebra again, just let me know. Send me a text or email me. It's on the Google Classroom. But that's all we're going to do for this is just move these around and record our angles. Did anyone want me to do more examples, or do you guys think you guys have this down? All right. Cool. All right. Does the sum of interior angles change as you move? So it's talking about this part. It's talking about this. This should always be 180. We've already used this in some theorems before. So no, sum of the interior angles is always 180 degrees. And just, you know, write how you did. You guys, like I said, we've kind of used the fact that triangles have 180 before in other theorems. So this should be pretty simple. If you had difficulties, again, just give a brief description on why you think it was a little challenging. You know, it helps. Like it honestly helps to write down what you thought was challenging. There's times where you might have difficulty with something and you just honestly need to just keep asking yourself, well, what did I have trouble with? I didn't know that. Why didn't I know that? And it does help you learn. So that's why those evaluations are there. It's not just so we can give you another assignment. It's so you have the time to reflect on what you found difficult. So from this, we're going to say that all triangles have 180 degrees. All right, so now we're going to list a proof. All right, so the first proof says, given this triangle, the sum is equal 180 degrees. So we're already given a triangle that has 180 degrees. So what are we given? We're given that angle 1, angle 2. So if we look at this diagram, they're talking about this triangle. So angle A, B, and C form, let point form a triangle given, we're going to prove that equals 180. Okay, so we're given that it's a triangle. So what are we given? ABC and ABC makes a triangle. Defining parallel line and labeling angle. So we're going to construct a parallel line. Why are we allowed to do that? Because of the definition of a parallel line. So we're going to say, let DE passing through B be parallel to this. So if you guys need to see that, that's this. And we're able to do that just by defining and labeling angles. Alternate interior angles are congruent. So if we look at this again, we're saying alternate interior angles are congruent. So this line, I know it's been a while, but we have done alternate interior angles. So alternate interior angles would be 4 and 1. So we're saying that 4 and 1 are congruent. So if we're looking at that, alternate interior angles are congruent. We're looking for angle 1 equals angle 4. Oh, and I guess angle 5 equals angle 3. Okay. And we're going to be looking at the measurements. The measurements equal each other. Oops. Oh, they're congruent. I see. So they're congruent, and from there we can say the measurements equal each other. I feel both of these should honestly be the same thing for the same reason. So this just to me feels repetitive. What does the theorem say? Oh, they say that the angles are congruent. Well, what does that mean, that the angles are congruent? So it feels a little repetitive. All right, so the next thing is defining a straight angle. So a straight angle is a straight line. So when we're talking about straight line, we're talking about 4, 2, and 5 equal 180. So 4, 2, and 5 equals 180. So as we look at this, we're saying that 4 is equal to 1, so we can replace 4 with 1, and we can replace 5 with 3. So that's how come we get this 1, 2, 3 substitution. Did that make sense? Did anyone have any trouble following the proof? All right, cool. So that's how proofs are. I've seen a lot of students just drag it in until they get it right, but try to understand it because it helps you do the proofs for the activities. Based on the angles of isosceles. So the idea of an isosceles triangle is that this side, let me use a different color. I'll use yellow. This side is equal to this side. And I have a feeling Edmentum's going to prove to us that this angle has to equal this angle. But all we know about isosceles right now is that this side equals this side. That's why I put one little mark. They're equal. All right. So let's get into base angles of this. So first, we're going to open up our GeoGebra. We're looking here, and it wants us to find the sides. So there's two ways of doing this. We can go into our measuring tools. We can click B and C and B and A, or you can literally just click the side and I'll tell you. I kind of like doing it this way because it tells you what side you're measuring. Oops, I accidentally did it for perimeter. Undo, undo, undo. It lets you know what side you're measuring. What side am I measuring? Oh, this is BC. This is helpful for when you accidentally like move these around. Because if I do something like this and I had it the other way, it'd be really hard to tell which one's which. But because I did AB, it tells me what it is. So we found out that these are congruent. What is the relationship? What kind of triangle is it? So AB equals 4.57 and BC equals 4.47. And this is asking us two questions. What's the relationship? Both sides are congruent since this is true. Triangle ABC is isosceles. It's at least isosceles. It could be equilateral, but all we know is that those two sides are congruent. Find and compare the measurements of angle C or BCA and CAB. All right. So when we're measuring this, BCA is basically just angle C. Like I said, you can just ignore the other two and just be like, oh, it's angle C. So we want to find angle C and angle A. So here we're going to grab our angle measuring tool, click our 3 points, so B, C, A, and then we're going to do, we want to go counterclockwise. So we want to go from C to B. So we're going to go have the A in the middle, A or C, A, B. And we find that they're congruent. So what I'm going to do is I'm going to do this the lazy way. This. I'm going to do measurement equals because I don't want to do the congruent sign. So the measurement of this equals 63.43. Again, I'm not too particular with it, but if you were to say this, it would be wrong because it's not a measurement. You would have to say that angle is congruent to. It's weird. I'm not too picky with it because a lot of my geometry teachers in college were picky with it. Like I took transformation geometry and advanced, what was it called? It's just like advanced geometry with some other subtitle. And they were really picky about that. And it was frustrating. So I'm not too picky of this, especially since it's high school geometry. But it is technically wrong if you do it the other way. All right, and we're going to answer basically the same questions. What do we notice about the angle measurements? So, angle measurements are congruent. You can even say that they're equal because we're talking about the measurements. If we were talking about the angles themselves, we would say that they were, we have to say that they're congruent. The measurements are equal because they're the same number. A measurement is a number, and angle is a physical angle. So the angle measurements are equal. So now move the vertices around and compare. What do we notice? So they want us to move this around. How are we? Oh, I didn't have it on the move option. So if I move this around, notice how they stay the same. That's because they fixed it. So these move. So if I change the side of A, it changes the size of C here. So if I move this around, I notice that they stay congruent and the angles are also still congruent. So because they format this so it can always be an isosceles triangle, we're going to see that they're always congruent. Like I said, it was something I knew before. You guys probably knew it too, but they want to give you a reason for it. So when moving the vertices, the triangle remains isosceles as well as the fact that the base angles base angles are base angles are these two angles at the bottom. This is your base of your triangle, so the base angles are the angles on the base. The base angles as well as the fact that the base angles remain congruent. So basically what we're just saying here is when we move it around, it stays in isosceles triangles and the base angles remain congruent, as well as, you know what, I can just say as well as the base angles. Because I'm saying that it remains congruent as well as the base angles remain. The base angles, well as, no, I like the way I wrote it before. It was a little long-winded, but it explains that the base angles remain congruent. Again, use your own words because I tend to get really picky with my words. As long as I can understand your reasoning, that's fine. And I want you guys getting used to using your own words for when you do the activities. And then here you can just write what you were having trouble with. If you didn't understand what a base angle was, that's a good spot to write about it. Find and compare measurements of base angles. Yeah, I think that's probably going to be the spot where people have the most difficulty is understanding what a base angle is. All right, moving on. How come it doesn't tell me how many slides there are? So here it's just saying that these two are going to be the same. I'm not sure why it's talking about an angle bisector here. So angle bisector is a ray that divides this. So a bisector just cuts it in half. So I'm assuming what they're going to say is that if you have two 90-degree angles and you bisect them, that they're going to be equal. But to prove the theorem, we first need to define an angle bisector. Oh, okay. So they're giving you a heads up on why this theorem works, and they're like, hey, this is what an angle bisector is. We're going to need to use this for the proof. So this proof here is going to have an angle bisector. So the first thing we see here is we have this triangle, this one right here, and we're going to say that it's an isosceles triangle. So the given fact is that we have, what is this? These two triangles to create point D. There we go. We're going to say that they're congruent by looking at this. So anything that's given, it doesn't have to be said. It can also be observed. So they did tell us that AB is equal to BC. Okay. So never mind. Looks like Edmentum's really good at stating all the facts. So that's given. They told us all this, so we have that there. Next, it's like we want to construct an angle bisector. So what we said what an angle bisector was we cut an angle in half. So get a point D on point AB, so it bisects angle this. So this is an angle bisector. I don't know what happened here. Somebody forgot to keep that link open, it looks like. But we know that this is a bisector, so we're going to write that here because we're creating a bisector. It bisects it. Well, obviously, it's an angle bisector. From here, unfortunately, they don't show us the picture, but what they're supposed to be showing us is, let me draw it real quick since they didn't show it to us. So here's our triangle. I believe they had B up here, A and C. And they're creating an angle bisector. Create a point on AC. So AC is over here, and it's going to cut this angle in half. So that means that angle BAD is congruent to DAC. Measurement of those. So this one right here with the D's. Just so we can make it official, D. All right, and then it says the reflexive property. That means that the same thing is equal to each other. So I'm willing to bet that's going to be line segment AD, because they're going to try to prove that these two angles are congruent. There are these two triangles, this triangle and this triangle, triangle ABD and triangle ADC. They're going to say that those are congruent, so I have a feeling that they're going to say that it's, oh, they don't. They're just saying that BD is equal to BD. Don't know why they're saying that, but okay. So by saying that, they're saying that angle, draw a point on BC so that, oh, AC. Wait a second. Sorry, guys. I drew that wrong. It's still the same angle because it's ABD, DBC. I should have been paying attention to this middle angle. I was talking about angle B. And that's why it says BD is congruent to BD. Okay. And then we're probably going to prove that we already know that these two angles are congruent because it's isosceles. So I'm going to make that a different color. So here we're going to prove that these are the same because of, give me a second. So we're going to say that we know that these two angles are these two triangles are the same because of side, angle, side, side, angle, side. So because we know that those are the same, we're going to say that these are the same. Why? Okay. I saw the first season of Umbrella Academy. Is the second season good, Jasmine? Sometimes I like asking questions on the chat to confuse everybody watching on YouTube later. For those of you that didn't come to class. Line segment. So we're going to say later on that there's another theorem. Another theorem is if we connect the midpoints, we're saying that this side is equal to this side, and this side is equal to that side. So a midpoint. But we're going to learn a little bit more than that. I think we're also going to prove that angle A and angle D are the same. But let's get into that. Just connecting the midpoints means that these are the same. All right. So let's get into this. So let's go into, let me close some of these GeoGebras out. The midpoint of AB, label it D. So we're going to find the midpoint. So we can find the midpoint by using, I believe it's this one. No, it's one of these gives us the midpoint. I could have sworn there was a tool that gives us midpoint. Ray. I could do a bisector, and that's like a super roundabout way of doing the midpoint, but I know there's a way to do the midpoint. I just haven't done it in a while. Ah, there we go. Midpoint or center. So we're going to go to our point, click midpoint or center, and it wants us to find the midpoint of AB and the midpoint of BC. If you do it in order, it's automatically going to label it D and E. So don't worry about that part for right now. It'll tell you if you need to relabel something. So midpoint of this, midpoint of this, got them down. Now the next part is, let's see here. Record the coordinates, BD. When you're through, draw a line. So we're going to draw a line. So I'm going to do a line segment from here to here. All right. And is that it? Okay. So obviously, since they gave us a blank space, we can't just leave this blank. So share it. So share your link. Save it, whatever you want to save it as. Usually I recommend putting your name just to show that it's yours. It just makes it easier for the teacher because we can always verify that it's yours by clicking it and seeing who submitted it. Oh, I didn't mean to just save it. I just wanted to share. I don't know why I click save. Share. I don't know why it's saving if it already saved, but okay. All right, that took forever. So we have our link. And extract the image as well, just so we can have the image. So download it. It will go to your downloads. Save it. Paste. Again, you can find it in your downloads, or sometimes you're allowed to do this. All right. So there you go. So the next thing it says is measure and record the lengths of AC and DE. All right, so we're going to measure and record AC and DE. So let's get into our measuring tools. Distance A, C, and D, E. Oh, it's going to prove this. Okay. Again, just extract your image. Since it's the same thing, notice how it didn't save. Give me a second here. No, not that. That. Since it's the same thing, it didn't have to it didn't ask me to name it again. I can just copy this link from before. Oops. Ah, copy the link from before, paste it, and this should give me the new image. So this link is going to end up being the same. Let me prove that. I forget how long GeoGebra takes. So, oh, it actually didn't. Oh, I did not know that, guys. So make sure you do share your new link because apparently it does need to save again to create a brand new link. Oh, now it should work. See how the link is exactly the same? So make sure after you have the link shared to save it. Saving it'll save it online. All right. Or just share link again. Share link again is better. Do that. Describe the relationship between AC and DE. So I'm going to say that the measurement of AC is twice the measurement of DC. Or you guys can say AC is twice as big as DE, or you can say that DE is half of AC. Either way, just talk about the measurement somewhere. Talk about that relationship that one is a DE, half the length. Is this making sense so far, everyone? Everyone good? Okay, cool. Cool. And Rebecca, I like Criminal Minds too. I've seen it a few times. I like those crime dramas. Change the positions of vertices A, B, C. So we're gonna change the positions of the corners. Vertices just means the corners of the triangle. So what we're gonna do, we're gonna grab this, gonna move this, and we notice that with some exceptions because of round off error, it still stays as half. Even though we change this, it's still half. Like I said, there's some round off error because if you cut this in half, we just round this off to make it half the length. So there's a little bit of round off error, but for the most part, they stay the same. Angle B doesn't do anything to change the length, but changing angle or changing side A, C does. So changing side AC does change the length. Changing B doesn't do anything. DE is dependent on AC. All right. So change it. Does the relationship? No. Relationship remains the same when changing the angles. And one thing you might write down, like I did, when I moved point B, the sizes didn't change. They only changed when A or C was moved. Even then, AC was, I'm going to write DE. DE was half of AC. The only reason why I like saying half is because saying AC is twice the length of DE, just, it's more words. How might you prove the observations about the slope in part D using algebra coordinates? Briefly outline the process. Oh my gosh. Find the figure created. So, how might you prove your observations about the slope of the mid segment? So we want to prove that these are the same. So that this slope has the same as this slope. So how do we prove that those are the same? Well, we need to take the coordinates. We would take two slopes. For the first slope, point E is x1 comma, I'm sorry, x2 comma y2, and point E is, should be putting these in parentheses. I should be doing more, but I don't want to like use this formula or the equation editor to write the thing. I'll show you guys how it's supposed to look like in the next one. But point D is going to be our x1 comma y1. Then we use the formula. This is why I said I was going to do it later. We're going to do, it's always rise over run, so it's always y2 minus y1. And remember, it's rise over run. Normally I don't have you guys doing this, but it said do it the algebra method. So I'm going to do it the algebra method. If your guys' formula is a little off, I'm not too picky. This is geometry, not algebra. But we're using this formula. And then, since I'm lazy, what I'm going to do is I'm going to copy that whole thing, paste it. I'm going to change this to, for the second part, for the second one, we're going to do point C is that, and then we're going to use point A is the other one, because we're finding the slope of both. We should find the slope of DE is equal to the slope of AC. So basically what I just said was we're going to find this slope. How do we find this slope? Well, we're going to have to find the rise over run. So we start at point D. That's why I made this the second point. I guess I could have written this backwards. D is x1, y1, and point E is that. But, I mean, it still works. So we're going to start off here, find our rise over run, and then for the next line, we're going to start off here, find our rise over run, and do that. In fact, if you guys don't even want to mention the algebra formula, I don't care. Just go like, we find the rise over run of DE. We find the rise over run of AC. We should find that the slopes are equal. That's way easier. And that's a more geometry way of doing it. To use the figure created to guide you. How will you prove your observations for question 4? Length of a midpoint briefly outline using parallel lines, midpoint lines guide you. What is this talking about? So what was question 4? Question 4 said that it remains the same. Okay, so we want to prove that it's half of that. So if we're saying that it's half of that, what we can say then is that this triangle is half of the other triangle. Yeah, I think Daniel has a good point on that question. Jordan, power what? Is it literally a show just called Power? And South Park is hilarious, Daniel. It's just called Power. I'm gonna look that up after. All right. So, how might you prove these? So we would say that top triangle is half the size of the total triangle. This is one I'm just kind of writing down. We're not going to say this. We're not going to go into official proofs because it's asking us to explain it by our observations. And it says we have to involve parallel lines, midpoint, and congruent triangles. So what I would say is, since BE is parallel to AC, which we already stated, and that takes care of our congruent part, the angles should be congruent. Since B is the midpoint of a B, and what was it? E is the midpoint of BC, two lengths are halved, meaning the third length is halved. So what I'm saying here is we have angle in the middle and two sides that are congruent. By the proof of side angle side, they would have been congruent triangles, but they are cut in half. So I used all of them there. So I might have used a little bit of creative language there, but the idea was still there. This angle, and so we have a side, angle, side. However, the only problem is since these lines are parallel and we have it cut in half, normally these angles would be congruent because the angles are remaining the same and we have side, angle, side. The only difference is this is cut in half. So if this is parallel and it's cut in half, they would normally be congruent triangles. It's cut in half. We're going to learn about this later. They're called similar triangles, where all the angles are congruent. But since we haven't really learned about similar triangles yet, I'm just using these creative words. And apparently you guys are both on episode 3. That's crazy. All right. So top triangles half. So that's a different way of doing this. But again, just try to understand what's going on and using these words. Always read your directions, guys. Read what they want from it. I've seen a lot of activities where people don't read the entire prompt and I have to take off points because they're missing part of the answer. And then just self-evaluate here. So we don't have that much time. Let me see what's going on. So this is just going to go into why these all make a triangle in the middle. Let me see how many slides we have left. We have a few slides left. Oh, wow, we have a lot left. 31 slides. We were at, give me a second. Triangle connecting midpoints. So I'll finish the rest off next time, guys. So it is going to change our schedule a bit. I'm going to change that anyway because of the fact that I was absent. So it is going to ruin a bit of the timing connecting these points of a triangle. So we'll start off with, where do we leave off? On slide 16, since that's exactly at half. All right. So, all right, guys. So if you guys haven't answered the question for today, let me go back to, where'd that doc go? Did I close the doc? Oh my gosh, I closed the doc. What's today? The 29/22 geometry. Our question is, what are the favorite shows? That's why everyone's like, I don't know what everyone's going on about right now. All right. Now they're talking, you guys are talking about songs. Regular show's really good. I like regular show. Write about what your favorite show is and why. In the chat box, if Daniel and Alonso to stop talking about songs, but just write about that in the thing. And you guys are free to go. Just let me know what your favorite show is, and we'll finish off this module next time. No problem. Have a good one. What's up, Alonso? About what? He just left? Episode 3 Clone Wars. Oh, that's a good one. Are you just writing in your favorite show, Giovanni? You're gonna go watch Daredevil right now? All right, that sounds cool. All right, later, man.